Hello everyone, myself Dhruv Soni. In this video, I'll explain how YOLO version 5 performs image classification. In this code, we have used predict.py to classify the images into different forms. Here we use three steps for classifying it: pre-processing, processing, and post-processing. In pre-processing, we first predict the images as a whole entity and not doing an object classification. And we predict that either the input is a video, audio, image, or a YouTube link, or a web stream. After that, we compress that, we classify that, and through a protected path we give it to post processing. In post processing, it is identified, and then it is via path folder, it is saved in a path. We also use update mechanism for cleaning up the spaces so that the power is used minimum and we can process the things in milliseconds. Thank you.
Hello everyone, let's understand the YOLO v5 classification training script and the performance classification validation script. It understands YOLO v5 is a powerful image classification model, fast, efficient, and ready for real-world deployment. It is not just an object detection but also image recognition classes. It loads the libraries, directories, device logins, and downloads the Sapphire, ImageNet, NetEase. The main model works as an torch vision, also like ResNet 50. The final layer matches the dataset classes, applies dropout, and every move to the GPU. The optimizer and learning rate scheduler loss function starts the main loop training. Each computes loss, update weights and accuracy, and log results to the model. It takes the best weights training results and gives commands for prediction, validation, and export. There is a called create classification data load which validates and models trained to the model's weight. The run function in the main loop works for the top 1 accuracy and top 5 to the lowest accuracy. It takes times to track process seeds and displays the result from process bar to TQDM. This both works in a simple and a basic way.
Hello friends, I will explain YOLO.py files. It's build and messages the entire deep learning architecture. It starts by the importing key libraries and the setting up paths so that all module likes model.commons and the util.general can be accessed easily. Then it brings together the core building blocks, convolution layers, C3 models, and the other essential component for the construction the networks. The detect class handle the object detection by the convolution features maps into bounding box, confidence scores, and the class prediction. This is where YOLO truly gets its name. You only look once. The segment class extends this all segmentations. The next base model defines how the data flows through each layers while detection model loads YAML configuration files and the automatics builds the full YOLO architecture. Backbone, neck, and the head, others modules like segmentation models and the classification adapts YOLO for the specific tasks. Finally, the parse underscore model functions dynamically reads YAML files and construct the models layer by layer. In short, YOLO.py acts like architecture reading blueprints, essential layers, and the preparing components trainable neural networks for the detection. Thank you.
Meet experimental.py from Ultralytics YOLO project packed with innovation tools to supercharge YOLO v5. First up, the sum class. It perform a weighted sum of multiple layers, letting the network learn how to prioritize each layer's features for smart merging. Next, mid-con 2D mixes different convolution kernel size like 1 by 1, 3 by 3, and 5 by 5 in one layer. This capture both small and large features, boosting detection across various object scale. And the assemble class combines multiple YOLO models into one powerful predictor, merging their outputs for higher accuracy and robustness. And finally, attempts load. A load simplifies loading a pre-trained model, auto-downloading weight, fusing layers for speed, and setting up single or ensemble models on CPU or GPU. In short, experimental.py equips YOLO with cutting-edge tools for feature mixing, assembling learning, and optimizing performance and pushing object detection to new height.